In this lesson, we will talk about piecewise functions. Now, in a piecewise function, you have two or more equations over a specific domain. In this case, we have three equations, and we're going to label them 1, 2, and 3. These are their specific domains. They are restricted for each equation to these domains. If you take a look at domain 1 and put it on a number line, you are looking at from negative infinity to 0. If you look at the domain of 2, you're looking at 0, which is open, to 2, which is closed. If you look at domain 3, you're looking at 2, which is open to infinity. If you took all three of these and crushed them down, your domain would be all real numbers. We have just split them up so that we have restricted the domain for each one of these functions. Now when we look at our functions, y equal 4 will give us a horizontal line at the y of 4. For the second one, y equals 4 minus x squared will give us a parabola that opens down. And for the third one, y equals 2x minus 6, this will give us a line, a slanted line, to the positive side. Our next step is to make a table of entries for each equation over its restricted domain. So we're going to make a table, an XY table, for all three of these equations using their restricted domain. In function 1, our domain says less than 0. So those are negative numbers up to 0. So negative 3, negative 2, negative 1, and 0. Notice this 0 has an equal sign next to it. Therefore, it's going to have a closed circle. The second one goes from 0 to 2. Notice that the 0, it's open, and at the 2, it's closed. The third one starts at 2 and goes on to infinity. And at the 2, it is open. At this point, if you look at the zeros, one is open, one is closed. If you looked at the 2's, one is open, one is closed. This maintains our function. So we can put it in your calculator, one step at a time. Go to y equals 4, and all your y's will be 4. The second function, if you put it in your y equal and you go to your table and you insert these x's into the x for the 4 minus x squared, you will get a 4, a 3, and a 0. Okay? And these are the parts that we're going to graph for this. In the third one, when you put 2 in, you can put this in your calculator, y equals 2x minus 6, and you plug these values in. When x is 2, then y is negative 2. When x is 3, y is 0. When x is 4, y is 2. So now we have our pieces. Our next step would be to sketch them on one graph. We start with the first one. The important point here is this last guy, the 0, 4. This is going to be closed. And notice it goes negative 1, 4, negative 2, 4, negative 3, 4. It is a horizontal line going to the left. The second part also is 0, 4, but it's open. Therefore, I still maintain my function. I am at 1, 3, and I am at 2, 0, and it's closed at 2, 0. This is the part of my parabola, so we need to make it curved. Remember the parabola that opens down. The third function, at 2, I am negative 2, but I'm open. Then I'm at 3, 0. Then I'm at 4, 2. I'm a line here, a slanted line. So here's your piecewise functions. Function 1, 2, and 3, all graphed on the same graph. The domain for this would again be all real numbers, from negative infinity to positive infinity. And the range would be my lowest y value, which is 2, with an open circle to infinity. So let's try another example. We're going to start again. We have 3 functions. We're going to label them 1, 2, 3. And we're going to talk about their restricted domains. In domain 1, we're at the negative 2. We're open, and we're to the negative infinity. At domain 2, we're going from negative 2, closed, to positive 2, open. And the last one starts at 2, we're closed, and to infinity. Again, if you combined all 3, you would have a domain of all real numbers. And it maintains a function because a vertical line test says one has to be open, one has to be closed. So let's talk about these individual functions. In your first function, you have a line, y equals negative x minus 2. This is going to give you a negative sloped slanted line. Your next one is a radical, which only can give us zeros and positives, and under your radical is a parabola that opens down. So somewhere along the line, it's going to be cut off so it doesn't go negative. And your third function is once again a slanted line to the positive direction. So we're going to start by making our tables with our restricted domains for 1, 2, and 3. In 1, our important point here is negative 2. We're only going up to negative 2, and this guy's going to be open. So we're going to have a few negative numbers in here. In the second one, we're going from negative 2 to positive 2. Notice my negative 2 is closed, my positive 2 is open. In the third one, I'm starting at 2, and that's closed. And we'll give it a few positive numbers. Your next step is to insert these values into each one of those functions. You can use your calculator and pull up your table of values the same way. So let's start with the first one. We plug in a negative 4, we get 2. We plug in a negative 3, we get 1. We plug in a negative 2, we get 0. Notice the slope is going down, and we have a negative 1 slope. In the second function, we plug in a negative 2, we get the square root of 0, 0. We plug in a negative 1, we get the square root of 3, which is approximately 1.732. We plug in the 0, we get the square root of 4, which is 2, and because this is a parabola, it turns the same way. And in the last equation, we plug in a 2, we get 2 plus 3, 5. We plug in a 3, and 3 plus 3, 6. We plug in a 4, and we get 7. And notice the slope going up by 1, and we did have a positive 1 slope. Our next step is to graph them on one set of axes. In the first function, the most important point is the last one, negative 2, 0, and it's open. We have negative 3, 1, negative 4, 2. Remember, we have a slanted line in the negative direction. The second function, I've got a 2, 0 and a negative 2, 0. This guy is now closed. So we have a closed function inside of our open function. So kind of represent the little closed circle inside the open circle. And the turning point up here is 0, 2. So our parabola is turning this way. Remember, it can never go into the negatives because it's under a radical, and your radicals can never yield a negative number. In your last one, your most important point there is 2, 5. So at the 2, we come up to 5 and we're closed. Again, we're still a function because this one's closed and the one below it is open. And we were a line that went up like this in a positive direction. So this is our piecewise function. If we looked at all our domain, again, our domains would be all real numbers. Our range, notice we start at the 0 down here, and we can use 0 to infinity. So these are your piecewise functions.